So in this video, we're going to be talking about the box method for factoring. It's a method that'll make you ask,
what's in the box?
And to answer that simple question, well, we have to move on. So in this case, our first problem is x squared plus 3x plus 2. So what we have to do in this case, because this is plus, is we need to figure out two numbers that end up multiplying to be 2 and also happen to add up to be 3. So the only numbers that multiply to be 2 are 2 and 1. And sure enough, they add up to be 3. So I go into a box like this. Our first one will be x squared. Our last one will be 2. And in the middle, 2x and x. So now what we're going to do is we're going to just look. X and x squared, our common factor would just be x. X and 2x, our common factor is once again x. Between x and 2, our common factor is 1. And between 2x and 2, between 2x and 2, our common factor is 2. Meaning our final answer would be x plus 2 times x plus 1. Now let's try another problem. So in this case, what we end up having is, you'll notice it's a difference, but it's two numbers that have to multiply to be 40, and yet also have a difference of 3. So in this case, let's think of our numbers that multiply to be 40. 1 and 40, 2 and 20, 4 and 10, and then of course 5 and 8. Now of these, the only ones that have a difference of 3 are 5 and 8. So we do our box. X squared, negative 40. Now, in this case, 5x and negative 8x, because we have to end up having the larger number be negative, so that we can end up having a negative 3. So, first thing we do, x squared and negative 8x, our common factor is x. X squared and 5x, our common factor is once again x. 5x and negative 40, our common factor is 5. Negative 8x and negative 40, our common factor is negative 8. So x minus 8 times x plus 5. And that would be our factors. Alright, for our next one, what we're going to need to do is we're going to do one with a leading coefficient that is not 1. So in this case, our leading coefficient is 2, and our constant is 5. So we do 2 times 5, that is 10. So we need two numbers that multiply to be 10 and have a difference of 9. Let's see, 1 and 10, 2 and 5. Of these, the one with a difference of 9 is 1 and 10. So in this case, we need to create our box. 2x squared, negative 5, 10x minus 1x. Now you don't actually have to write the 1, but it can be helpful whenever you're trying to think of things. So let's see. The greatest common factor between 2x squared and negative 1x is just x, whereas our greatest common factor between 2x squared and 10x is going to end up being 2x. So far, x times 2x, 2x squared. So far, so good. Negative 1x and negative 5, our greatest common factor is, in fact, negative 1. So one of our factors is 2x minus 1. Now we have to deal with our other one. 10x and negative 5, our common factor is, in fact, 5. And we can confirm this by going x times negative 1 is negative 1x, 2x times 5 is 10x, and negative 1 times 5 is negative 5. So our final factor would be x plus 5. Let's try one more. So remember, the first thing we do, 4 times 3 is 12. So I'm looking for two numbers that multiply to be 12, and they'll both be negative in this case. So let's see. We have, oh, and they have to add up to be 8. So 1 and 12, nope. 2 and 6, and 3 and 4. And of those, 2 and 6 are the ones that work. So let's plug them in. 4x squared, 3, negative 2x, negative 6x. Alright, so let's find our greatest factors. In this case, we start with 4x squared and negative 6x. Our greatest factor is, in this case, 2x. Then 4x squared, negative 2x. Our greatest factor is also 2x. Now let's try another one. In this case, negative 2x and 3, our greatest factor we're going to actually say is negative 1. Negative 6x and 3, our greatest factor is negative 3. Now let's double check our answers. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. 2x times negative 3 is negative 6x. And negative 3 times negative 1 is positive 3, meaning our final factoring is 2x minus 3 times 2x minus 1. And that is how we factor by using the box method, so you'll never have to ask.
Oh, what's in the box?